right, good evening, everybody. It's 9 o'clock. This is going to be our spot every night through hurricane season to give you the complete update on what's going on in the tropical Atlantic basin. Today being June the 1st, it is the first day of hurricane season. So let's go. First of all, names on the list: Arthur, Bertha, Cristobal, Dolly, Edward, Faye, Gonzalo, Hannah, Isis, Josephine, Kyle, Lee, Marco, Nana. Nana, not Grandma. Hi, Nana. Omar, Paulette, Renee, Sally, Teddy, Vicky, Wilfred. So those are the names on the 2026 hurricane names list. We're in what is usually a quiet time of the season. Early on, we don't have much activity. Here we are, June the 1st, with activity typically very quiet to none. Every now and then, about every other year, we get a June storm. So far, modeling is quiet on that. We're going to look at the modeling. Peak of tropical storm activity is September the 10th. So you can see how we really start to ramp up in August, between August and the end of October. That's really the meat when we get most of our named storms in the Atlantic basin. If we're going to get an early season storm in June, it almost always happens here in the Gulf, Northwest Caribbean, up the East Coast. And this is actually interesting. So take a look. I pulled this up. June hurricanes since 1900, every one of them. These are hurricanes, not tropical storms, but ones that actually became hurricanes. And first thing let's do, let's just zoom in. Look at all the June landfalls of hurricanes in Texas. Brownsville, we had one in 1909. This is before they were being given names. 1913, one hitting down North Padre Island. Corpus, 1936, had a June hurricane. Had a 1929 storm, Matagorda Bay. 1921. Between Matagorda and Galveston Bay, we had Hurricane Bonnie in 1986. So 1986 is the last time Texas coast was hit by a June hurricane. Of course, in June, we've had tropical storms. One that stands out is Tropical Storm Allison, 2000, 2001. That was June 8th and 9th, the one that gave us a huge flood. The one that was off the charts, never to be repeated again, until Hurricane, I'll remember it in a little bit, the big storm that flooded us that came in from the west. Audrey, 1957, this is an interesting one. That is one that became almost a Cat 4 in the month of June, so we can get major hurricanes in June. Had one, Vermilion Bay, 1934. And then you see Agnes, Alma, and the 1945 hurricane over there just north of Tampa. But I wanted to back this up because you can see, look at where these were all born. Either in the Northwest Caribbean, born in the Gulf, one born over the Yucatan here, Western Caribbean. So, you know, all within that statistical area, shaded area, that shows if we're going to get a hurricane or even a tropical storm develop this time of the year, it's Gulf, Northwest Caribbean, or up the East Coast, or they travel up the East Coast. Once we get later into the season, September, the peak of the season, that's when, you know, the Atlantic opens up for business and we can get quite a bit of development out here. Those are your longer track hurricanes. The ones that really can catch you are the ones that develop in the Gulf, and you only have 1, 2, 3 days to prep. A great example of that, Alicia in 1983. This was an August hurricane that developed right here as a little tropical storm hurricane, and then all of a sudden overnight became Cat 3 and came inland. That was the last time we were hit by a Cat 3. But that's a perfect example of a homegrown storm in the Gulf that developed right on our doorstep and became a major hurricane. So the forecasts, there are 2 of them. This is from NOAA. They're forecasting 8 to 14 named storms. Average is 14. Hurricanes 3 to 6, average is 7. Major hurricanes 1 to 3, average is 3. So the forecast is for a little bit below normal in total storm count, total named storms. That's from NOAA. And then Colorado State University is very similar. They're forecasting, they put a hard number on it. They're forecasting 13 named storms. Average is 14. In 2025, we had 13. So we would have a below average season, but only by a storm, and we'd match last year if we ended up getting 13 storms. And there's been a lot of talk about how we may have a below normal season because of El Nino. We'll talk about El Nino in a second here. But I want to just impress upon you is when you see these forecasts for the number of storms, number of hurricanes, number of majors, this should mean really nothing to you except it's time to get ready in case this is the year we get hit by one. So if you live on the coast and you're in an evacuation area, where are you gonna go? Where are you going to stay? What are you going to take with you? Do you have animals, medicine? Do you have folks with medical issues that need to have oxygen? This type of thinking. Plan ahead while there's nothing out there so you can just get up and go and not be caught in a panic if a big one is heading in our direction. Those of you who were here during the approach of Rita in 2005 and the massive evacuation, the panic evacuation that we had here from Rita in 2005 will appreciate this. Just having a plan and being a little bit prepared early pays off big time when the real deal is happening. So let's talk about sea surface temperatures, talk a little bit about El Nino. We look at temperature anomaly. So this is a map not showing the exact sea surface temperature, but how much above or below normal the temperatures are to the 30-year normal right now. And there are a couple of things that jump out at us. You can see the Pacific is just glowing red. So we're quite a bit above normal as far as sea surface temperatures right now in the East Pacific. This is the equatorial Pacific. This is the El Nino region. And you can see how bright the red is here. So this is where our burgeoning El Nino is taking place. What is El Nino? It's an unusually warm surface temperature of the ocean in the eastern Pacific. That has significant statistical impacts on how the tropics go in the Atlantic side. So that's our El Nino region. We're going to talk about that a little bit more as we go along. We go over to the Atlantic side and you can see we're a little bit above normal, but we're a little bit above normal. We're not way above normal. Sea surface temps are above normal for this time of the year. They're actually cooler than they were this time last year by several degrees. So although we're above normal, we're cooler by several degrees right now compared to last year. But we're above normal, so we've got ripe conditions out there as far as sea surface temperature goes. Let's talk more about the El Nino and how this impacts the jet stream. And so I was just outlining this area. This is where we've got that warming taking place. There's our El Nino zone. It's along the equatorial Pacific. And what normally happens in a normal and a non-El Nino year is this. The trade winds at the surface blow east to west, and what they normally do is they will blow the warmer water to the West Pacific, and it allows cool water to upwell off the west coast of South America. That's a normal year. Pushes the warm water to the west, over toward Indonesia, and there's Australia. Well, in an El Nino year, those trade winds, they just don't show up. They don't blow very hard. They're much weaker than normal, so they don't blow the warm water away. And it just builds up here in the East Pacific. And that can create a general area of low pressure, bringing a lot of rain to the west side of South America. And this is a couple of satellite images from NASA showing what it looks like when you have an El Nino. Look at all the warming right there. There's your equatorial Pacific, and here's the 2015 El Nino. And some are stronger than others. This was a very strong one in 1997. This one was not as strong in 2015. This year's El Nino is forecast to be the strongest on record. So it would be stronger than the 1997 El Nino. If that happens, ramifications for the U.S. and the Atlantic hurricane season might be significant. Here's why. It's complicated, but what this ends up doing is increasing the upper level wind shear across the Atlantic basin. So you get more mid and upper level shear. That's just winds blowing at 5,000 to 15,000 feet or more, blowing in from west to east. That's one of the major impacts of El Nino on the Atlantic side. So why is that important? Why would that reduce the number of storms in the Atlantic? Well, to get a healthy hurricane, or a healthy storm, if you will, it needs to be vertically stacked, perfectly up and down. So there's nothing interfering with the circulation or the growing organization of a developing tropical system. This, what you're seeing here, is more depicted of a mature hurricane, where you can look down from space and see the eye and see the surface of the ocean right in the eye. It's perfectly vertically stacked. This is an unsheared storm. They can grow to be your major hurricanes, and they can do that quite quickly in an unsheared environment. So when you get the wind blowing across the mid and upper levels of a developing storm or a developed hurricane, it will very quickly interfere with that circulation. It can tilt the storm over, and so you can see how, tilting that rotation is going to disrupt it, and that's exactly what happens. It can disrupt it so much that it either weakens the storm, or the storm can be ripped apart, or it can be a developing storm that just never gets a chance to form, because it can't get going in that hostile environment where you've got those upper level winds ripping across the mid and upper levels of the developing storm. That's why wind shear can lower the storm count. It can lower it. It doesn't mean it's going to. This is not like, for sure, it's going to cut the storm count by this much. That's not how it works. Just in general, statistically, we have seen that when you get this, it can reduce the overall number of storms. Another thing that keeps the open Atlantic quiet early in the season, and why the Caribbean, the Gulf, and the East Coast are more active early in the season, is the dust. So this time of year, we've got the creation of a lot more Saharan dust out over the open Atlantic. You've got convergent zones over Africa. It creates thunderstorms. You'll get a trough that can actually become kind of like a quasi-front over equatorial Africa. And that creates outflow at the surface. So you get these strong winds, and it kicks up the dust up here from the Sahara Desert, kicks it up into the atmosphere, 5,000 to 15,000 feet. The trade winds blowing to the west then carry out over the Atlantic, and that's what you get. You get dust coming out over the main development region here in the open Atlantic, and you get a lot more of it in May, June, and July. And then in August, September, quite often, that dust will begin to subside, and that can lead to more storms. The dry Saharan air layer, as it's called, is an area of dry, sinking air. And that sinking air, that's exactly the opposite of what storms need to develop. They need warm, humid air to be rising. So that dry air, it sinks, the warm air sinks, and it just zaps storm development out here quite often early in the season. So that's a big reason why you just don't see development out in the open Atlantic. Even if sea surface temperatures are warm enough, you don't see it quite so often because of that dry Saharan air layer. So what's going on right now? Let's look at the modeling. Last week, models for this week were suggesting at some point a little weak low pressure might try to form in the Gulf. We're not seeing that. We're seeing a whole lot of rain over the Gulf of Mexico. And that's going to help to lead to a daily rain chance here starting tomorrow and the rest of the week and the weekend. We'll get tropical moisture coming in. But we don't see any type of isobar closing off a low developing over the Gulf this week. So what would that look like if we did see something that would be concerning? It would look like this. And this is an area of low pressure that's forecast to form off the East Coast by Thursday, Friday. This one will be racing into the open Atlantic. This one is non-tropical. But that's the type of isobar where you've got them stacked one on top of the other, lines of equal pressure, all concentric. That would be a developing low pressure area, and that is what we do not see in the modeling over the Gulf. Here's another look at it. What you're looking at is the Euro, the GFS, and the graph, our in-house model. And right now we have low pressure up here off the coast of Nova Scotia and Newfoundland. This is just a warm air desert, kind of a low, getting warming out over the desert with the rising air, but you see none of that over the open Atlantic, the Caribbean, or the Gulf. And I'll put this in motion. And just, this is just the type of thing I look at first thing when I come in, is anything looking to develop out here in the Atlantic Basin over the next several days? And the answer is no. Nothing in the open Atlantic, nothing in the Carib, nothing showing up in the Gulf of Mexico. So no surprise, as we go into the first week of hurricane season, things are quiet. And just looking down from outer space, tropical satellite, this is a color enhanced satellite. So the brighter colors represent the colder cloud tops that are going up to 40, 50, 60,000 feet. The higher up they get, the colder they get, and those are the colors. But underneath those cold cloud tops is where you have the deepest convection, the strongest thunderstorms. So we like to colorize it. It helps us to understand a little bit better about what's going on with the dynamics of the storm. And there's some heavy thunderstorms this afternoon and this evening over the Yucatan, and some of the cloud debris is heading out over the Gulf, but none of that is tropical in nature. Again, the type of thing that we look at constantly this time of the year to see if there's any hint of development. We don't see any. Hurricane Center does not see any development there today or for the next 7 days. Now, next 7 days, several times this season, we'll put up the Hurricane Center outlook, no development in the next 7 days, and the next day, there'll be a spot where we could see development, 40, 50, 60% chance. So that's, that can change overnight. So that's why I urge you to either watch this every night at 9 o'clock. This is a great place to get everything that's going on out there, especially when things get busy later in the season, or just get it from somewhere so that your family and you don't get caught off guard in case we get an Alicia homegrown here coming out of nowhere and ends up giving us a major storm. I went one graphic too far. High temp today went to 94 at Bush Intercontinental Airport. Okay. We'll call it an evening. Things are quiet. Have a plan. If you're inland, be prepared to camp out at your house without electricity for 5, 6, 7 days. Water, food, canned goods, dog food, medicine for a week, because if we were to get a big one, you're just not going to be able to get up and do normal life for a week or more, if that were to happen this season. We'll see you tomorrow at this time at 9 o'clock for another update on the tropics.